Okay, so get ready for some seriously mind-bending physics today, because we're diving deep into Albert Einstein. And not just his general theories, but his actual words
Yeah.
on this topic
Yeah.
that still has physicists kind of scratching their heads,
Mm-hmm.
which is ether. We're taking a deep dive into a 1920 lecture that he gave called Ether and Relativity Theory.
Okay.
And yes, you heard right, ether. That mysterious concept that you might remember from way back in high school physics class.
Yeah.
Where scientists used to believe that it was this invisible substance.
Yeah.
That filled all of space, the air of the universe.
Right, exactly, yeah.
This cosmic medium that light and gravity traveled through.
Yeah.
So before Einstein came along and shook everything up, scientists had this problem, which is, how could anything act across empty space? Think about it for a second. We as humans experience the world through touch, through direct contact.
Right.
But then you've got things like gravity acting over these mind-boggling distances. So how could a force be transmitted with nothing in between? It seemed impossible.
Yeah, you've hit on exactly why this idea of action at a distance was so troubling to these early physicists. They needed something to kind of bridge that gap, right?
Right.
Some way to explain how these forces could be operating without a physical connection.
So ether was their solution.
Yeah.
It was this cosmic ocean that everything exists in.
Precisely. Ether was their way to make sense of these forces like gravity, to give them a medium to act through.
Okay. And then we discovered light waves. Didn't that just further solidify this whole idea of the ether? Because light acting in these ways made scientists think it must be traveling through some sort of medium.
Yeah.
So it had to be ether, right? What else could fill the vast emptiness of space?
It seemed like such a perfect fit at the time, until this Scottish physicist came along by the name of James Clerk Maxwell, and he really threw a wrench in the works. So Maxwell, in the mid-1800s, he developed these equations that described electricity and magnetism. And nobody had ever done it this way before. What's really cool is that these equations also predicted the existence of electromagnetic waves, which we know today is light.
Oh, okay. So it wasn't a surprise that light acted like waves then.
Yeah, exactly. But here's the thing. Maxwell's equations, they worked too well. They described light perfectly, but they didn't leave any room for this mechanical ether. The kind that could be jostled by waves. You know what I mean? It's imagine you're trying to make ripples in an ocean that's not actually made of water.
Right.
Just wouldn't work.
So what happened to the ether then? Did they just give up on it?
Not quite. So this physicist named Hendrik Lorentz, he came along, and he came up with this new version of ether.
Yeah.
That was so subtle and so non-interactive that it was basically undetectable.
Undetectable ether. How does that even make sense?
Okay, so imagine a perfectly still pond.
Okay.
It's made up of water molecules.
Right.
But you can't actually see them moving, can you?
Right.
Lorentz's ether was like that. It was just the static background, totally unaffected by the movement of matter or light.
Okay. I think I see where this is going. So then Einstein comes along.
Right.
With special relativity.
Mm-hmm.
And he just chucks this whole idea of ether out the window.
Right. It's not quite that simple. It's true, the special relativity. With this idea that the speed of light is constant, it made ether seem unnecessary.
Okay.
Because if the speed of light never changes, you don't need some special medium for it to travel through.
Right.
But what's so interesting is in this 1920 lecture, Einstein doesn't dismiss the idea of ether entirely.
Right.
He actually proposes a completely new way of thinking about it.
Okay, this is where it gets really interesting. So he discarded the old ether, but now he's hinting at this new kind. I'm intrigued. What did he have in mind? A new kind of ether. Okay, you got to tell me more. What was Einstein getting at?
So he starts by saying, yeah, the old ether, it has some problems, especially with special relativity. But there's this thing, he points out, even if you have special relativity, some stuff is hard to explain if space is just empty.
Okay.
He talks about inertia, that thing where objects don't want to change how they're moving.
Right. It takes way more effort to push a car than to push a shopping cart.
Exactly. And Einstein's point is that this resistance, this inertia, it suggests that space itself has got to have some properties, some structure that can actually influence matter.
Interesting.
And get this, he even uses the word ether to describe this.
So not a physical substance anymore, but more like a set of rules for space itself?
You got it. Einstein's new ether wasn't something in space, but a fundamental part of space itself. And this is where it gets really wild. He says this ether, this structure of space, is what gives us gravity.
Whoa, hold on. Are you saying gravity is just a consequence of how space is structured?
That's exactly what he's saying. It's the foundation of general relativity. See, in general relativity, gravity isn't some force going through space. It's actually a curvature of space itself. And that's caused by mass and energy.
Okay, so instead of an ocean, we've got space as this flexible sheet that can be, like, warped and twisted. And those warps are what we feel as gravity.
That's a great way to think about it. Just like a heavier object makes a bigger dent in a sheet, a more massive object makes a stronger gravitational field because it warps space-time more.
This is blowing my mind. So Einstein, he didn't totally ditch ether. He just got completely redefined it. Not a substance, but the actual fabric of space and time.
You nailed it. And what's so cool is that this lecture shows Einstein wrestling with these ideas in real time, trying to figure out where this new ether fits in. He even wondered if it could explain other forces, like electromagnetism, maybe even lead to one unified theory of physics.
Wow, a unified theory, explaining all the forces in the universe. Einstein's ideas were truly something else.
It's incredible, right? Even a mind like his was still searching, still questioning. And his whole journey with ether shows us something really important about science sometimes. To find the answers, you have to completely rethink the questions you're asking.
Well, I couldn't have said it better myself. And for our listeners, if you want to dig into Einstein's actual words on this, we've got a link to his full lecture in the show notes. Trust me, it's a fascinating read. Until next time, stay curious and keep on exploring the universe, folks.